Welcome to the video tutorial on microprocessors and microcontrollers. This is lecture 7. In this tutorial, I'll be discussing about the interfacing part of I/O devices with 8051. Going with interfacing in general way, let's define interfacing is a shared boundary or a connection between two different devices or systems through which information is being passed. So it is a common connection or a common protocol or a common circuitry which will be shared between two different devices so that they can have a communication with each other. That is an interface, and in general the I/O interfaces can be classified into serial I/O interface or a parallel I/O interface. As the name says, the serial I/O interface, in these two devices will be communicating with each other serially, that is bit by bit. So here if you take a transmitter and this side is a receiver, transmitter will be transmitting a data one bit each time, maybe say from D0 to D7. If it is of 8-bit wide data, then each bit will be transmitted from a transmitter to the receiver, and the receiver will be receiving data bitwise. Depending upon the implementation, it may be implemented that the transmitter will be transmitting LSB D0 first and MSB D07, and similarly in the same way receiver also will be receiving. Whereas the other implementation, it could be the transmitter will be transmitting D7 MSB first and D0 LSB later. So in the same way receiver also has to receive the data. This is what is the common understanding and a common interface between a transmitter and a receiver, or device 1 and device 2. The same way in the parallel I/O interfacing, the two devices will be connected to each other in a parallel fashion. So we will have more than one connection between transmitter and receiver. For example, transmitter from D0 to D7 for 8-bit data will have 8 dedicated lines between the transmitter and the receiver with the corresponding bit. The D0 of transmitter will be transmitting data to D0 of a receiver. Likewise up to D7 here and D7 here also. So if we look at the speed and the amount of data being transmitted from transmitter to the receiver in a given amount of time, this parallel I/O interface will be carrying more data in comparison with the serial I/O interfaces. Here for example, in single clock, if a data is being transmitted, and assuming that a single clock is of 1 second, then transmitter and receiver, the data transaction between these two devices will take 1 second to transmit 8-bit data, whereas the same 8-bit data with the same set of a clock cycle may take 8 seconds of time. So here with respect to the speed wise, that parallel I/O interface is faster compared to serial I/O interface, whereas with respect to the cost of implementation, parallel I/O interfaces will be costlier compared to serial I/O communication. So there are some advantages of serial interfaces and disadvantages of serial interfaces, similarly to the parallel interface also. Depending upon the implementation, depending upon the requirement, either of these interfaces will be used to interface I/O devices with a microcontroller or a microprocessor. So let's go with interfacing some I/O devices to 8051. So here I have chosen one input device and one output device to connect to a 8051. So first let us discuss about how we can interface LED, which I can say is an output device to 8051. Now these are the practically available LEDs. LEDs are almost similar to our diode. So each LED will be having two terminals, like it has anode which is little bigger in comparison to another LED which is smaller to this. So this anode and this cathode, when anode is connected to the higher potential and cathode is connected to the lower potential, then this LED will be glowing. and here I can connect this anode of a LED to a microcontroller 8051 and cathode can be grounded. So in that case what happens is, in order to glow this LED, we have to send logic 1 from the microcontroller pin to this anode, and anyhow cathode is grounded, that time this LED will be glowing. The reverse is also possible. We can connect cathode to the pin of microcontroller and anode can be connected to the power supply. So in order to glow LED, then microcontroller has to send 0 on its pin which is connected to cathode, then this LED will be glowing. So you can see the practical circuitry for interfacing LED here. So here this is an external LED which will be connected to microcontroller through a current limiting resistor, and these are accessory circuit for providing frequency externally, and this is a reset circuit which is connected to 8051. Okay, so let's look at how we can interface LED with 8051. There are different ways of connecting LED to 8051. Let's look one by one case wise. Coming to the first case here, a LED, this is LED. It has a cathode which is connected to the port pin, and the anode can directly be connected to the power supply. So in this case what happens is, there are no opposition to the flow of current. So in order to glow LED, the port pin has to give logic 0. When it is given logic 0 which is equivalent to ground, there are chances that the current of this power supply may be heavily flowing through this LED to the port, and chances that the LED may fail or burn, and similarly even the port pins are completely, the IC also may be burned. So this is not a good choice for connecting LED to a microcontroller. There is another configuration which is possible. Instead of connecting anode to a power supply, we can connect the anode to the port pin of microcontroller, and cathode can be directly grounded. So here in this case what happens, more current may not be flowing, but there is a limitation that every pin of the port of any microcontroller will be carrying or will be giving limited amount of current at the output. So there are chances that current which is given by output current which is given by a port pin may not be sufficient to drive LED, or may not be sufficient to make this LED brighter. So this LED may be too dimmer. So this case is also not advisable to connect interface LED. Then the third case, and which is the final case here, is the cathode of LED may be connected to any port pin, and anode may be connected to the power supply through this resistor, and this resistor we call it to be current limiting resistor. So in order to glow this LED, make it on, we have to send 0 on this connected port pin, then this side will be grounded and the other side we have higher potential, hence LED will be on. When LED is on, a limited amount of current will be flowing through this resistor as well as this diode, and so this LED, hence the chances that this LED may not be burnt out. Rather, we can control the amount of current which is flowing through this LED by this equation. Since every LED may drop some voltages across this, maybe say it is 1.7 volt, and it may need around 10 milliamperes of current. So we can see how much of current can be flowing, or we can control how much of current can flow through power supply to LED and to the port pin. So it may be 5 minus 1.7 divided by R. So appropriately choosing the value of R, we can control the amount of current which will be flowing. So hence in this case, the required amount of a current can be sent by increasing or decreasing the value of resistor. Hence you can say this is a good practice. So in the following examples, I'll be using the same setup for interfacing LED. Let's see here. This is a LED connected through power supply and through a current limiting resistor. The same setup is interface to maybe say second pin of port 2 of 8051. This is how I'll be interfacing IO device, that is LED to 8051. Right. So let's look at the practical circuit of this. This is the practical circuit of 8051. 8051 is a 40 pin IC where 40th pin is given to VCC, 31st pin is also given to VCC, 20 pin is grounded, and this side pin number 18 and 19 will have a crystal oscillator to generate the frequencies. Similarly, at pin number 9, which is RST, we have a reset circuit. This is generally a power on reset circuit. Now to this particular circuit, I can interface LED here. So let LED, cathode of the LED is connected to pin 27, whereas it is the sixth pin of port 2. You can see here P2.5, that is sixth pin of port 2 is connected to cathode of the LED, and anode of LED is connected to some 10K resistor which will be connected to VCC. And this is the hardware setup for interfacing LED. In order to make this LED work or glow, then we have to write a code, and that code need to be burnt into the ROM of this 8051. So let's look at the code. The code here, see the logic here is CPL. Start with org00, then we have a loop here. This statements between this loop will be continuously executing, and the first statement is CPL, complement the digit, complement a bit here. So the bit referred here is 2 to P2.5, that is sixth pin of port 2 will be connected, and when you execute this, if this sixth pin of port 2 was carrying logic 0, now it will be 1, and again next time when it is executed this will be 0. So 0 and 1 will be complementing each other after say certain delays and all. So once you execute this particular instruction, then we'll be calling certain delay here, say short jump delay. Delay is a routine which will be creating certain delays between two successive events. So in order to create delay, I have copied 01 into R2 and 02 into R3 register just to show in the simulation part also, which will be easy to show. Whereas depending upon the requirement, you can increase or decrease a delay by loading the content of R2 and R3, maybe with 255 is the limit and 255 here also. Then depending upon the requirement, we can choose the number, what number or what amount of integer value should be loaded into R2 and R3 so that we can get a required delay. Then once the control goes from this delay, again it goes to S jump, short jump to loop, it comes here. So whatever the earlier bit was there, that will be complemented now. If it was earlier to be 0, now it will be 1, and if it is 1, it will be 0. Since to this line, to this pin, I have connected LED. So if it is 0, then LED will be on. If it is 1, LED will be off. So this is how I will be toggling this LED between 0 and 1. So this is how we'll be interfacing LED, and this is the hardware, and this is the code. Once we convert this code into hex file, that hex code can be burned into a ROM, and that this particular application will be blinking LED with a given delay. So this I'll show you how we can execute in Kyle software. So this here, open Microvision, then go to project, new project, then type the name of the project here, only say LED, then say save, then you'll get this menu, then go to device, then select legacy device databases, then come down here, then select generic option. When in generic option select 8051 all variants, say OK, then copy this, yes, you say yes, then already existing overwrite, yes, overwrite, then yes, now you go to target 1, then right click target 1, you will get the options for target. Then here you see it is 12 megahertz frequency should be selected for 8051. Then go to output, then check create hex file, because after compiling we need a hex file for burning. Then your this is ready, project is ready. Now you have to add a source code. To add source code, you have to go to file new, then add a start writing code here as an assembly code. Then I have copied the code and say save, then give the file name with a .asm extension, say led asm dot asm, it is assembly language code. Then say save, your file is created. You can check the color also, it is changed. Now you have to add this file to the source group. Say right click, add existing files to the group 1, then select the file which was created. So led asm.yes, this file has to be selected. Then say add, that file will be added here. Then say close. You can see the file there, led Now you have to compile this. Then now you see there are no warnings, no errors, it is perfectly fine. Then translate or convert that into hex file. Yes, hex file of that project is being created, that can be burned. Then you can go for simulation here. Here in, as you can see the simulation way, yes, say yes. This is a place where you can see how things are happening. Now since I have selected port to 2, then before execution you select even peripherals also, and that is a delay. Yes, go to peripherals, select IO ports, port to 2. Yes, bring it somewhere here so that easily you can visualize. Then you see all are checked. Yeah, go to this step execution. Yes, when you press this, control comes, then you see this bit is, now it is 0. Then execute stepwise. Yes, it has entered into delay routine. Then start executing. Then yes, it is executing. Yes, it comes to the next. Then when you execute again, it will complement the previous one. It has complemented. Then say 1 0 1 0, then 0. It is, then now you have, yes, you can go to this option. Then once you click this, you'll get 0, okay, get 1, then click again 0, and click again 1, click again 0. So this continues where you are connecting here led, hence led will be blinking. This is how we can see even on the menu also, that blinking will be with certain delay. Yes. Now let's see how we can interface push button with 8051. So even the same way that we have discussed LED, the same way we can see even push button also. This is a practically available push button. So when you press this, there will be some context which will be made. You can see here, right? This particular cap is representing A here, and internally we have a B and C. When you are pressing A, when you are pressing this button, then this B will make contact with C. Then when it is making contact with C, whatever is available at this end, the same thing may be available at this end also. That means if you are connecting this to ground, then when you are pressing, C also will carry 0 now. And if you are connecting this to a power supply, that is logic 1, then after pressing, the C will be carrying logic 1, that is plus 5 volt. This is what is the logic and working of our push button. This is again a symbol. When A makes contact with B, whatever is available here, that comes here. Let's use the same principle for attaching or interfacing push button to 8051. Let's look at different ways of connecting push button to 8051. Yes, this is the first case. It is possible that we can connect this push button. One end of the push button is grounded, then other end of the push button is connected to some pin of the port 8051, say. Then when you close this button, it carries logic 0. That is logic 0. Then inside the code you have to check this port pin and see whether it is pressed or not. So what happens with this particular configuration is, when it is closed, that this particular pin is directly grounded. So there are chances that a lot of current may be flowing from this IC to the ground. So there may be an internal pulling, hence chances that the complete IC may also be burnt, or a lot of drain may happen here. So this is not advised interface configuration. Let's look at another case where instead of connecting one end of the push button to the ground, we can connect one end of the push button to the VCC or a power supply. Then other end can be connected to some pin of the port. So in this case, what happens is, here when on closure, it will give logic 1. Okay, so what happens if the port is made as a 0, then the current from this power supply may directly enter into this IC. There are chances that this current may damage complete IC or microcontroller. So this configuration is also not advisable. Hence we can go for another case here. Here what we can do is one end of the push button is connected to the power supply, then the other button can be connected to the port pin, and the same point we can extend to the ground through this register. So in this case also, when you press a button, then it will give logic 1. So again the same way, the heavy current may also flow through a port pin, hence it may damage IC 8051 microcontroller also. So this is also not a good practice. So what we can do, we can use this, which is considered to be a very good configuration. Here one end of the push button is connected to the port pin, the same point is connected to the power supply through a register, then other end is directly grounded. So when you close this push button, then port pin will be carrying logic 0, else it will be carrying logic 1. So since power supply is connected to through this register, heavy amount of current will not be flowing. And moreover, here it is connected to the ground, the chances that this current will be directly connected to the ground, hence this will not be internal pulling also. So this configuration is a good configuration, hence I will be using this configuration for further interfacing. Let's look at again a practical circuit which has a reset and oscillator here that I already discussed with LED interfacing. Yes, let us interface a switch through 10K resistor here. Assume it is connected to 35th pin of this IC, then which is actually the 5th pin of port 0. So 5th pin of port 0, I connect one end of the push button, the same is connected to the power supply through this register, and other end of the switch button is connected to the ground. This is the hardware setup, and let's look at how we can read the status of the switch through a program. So this is the hardware setup, and this is a software part. Yes, org00, then end. In between this we have a code. Now here JNB P0.4 comma next. So what is done here? Jump on no bit. That means when this bit is not set, jump on no bit. When it is not set, it has to go to different location. So based on this, it can go to next, or if it is not set, it will go to this. So based on the condition of this fifth pin of port 0, either this will be executed or this will be executed. Assuming if this is true, when jump on no bit is true, then it comes to this one, CLR. What is CLR? Clear this bit. What is this bit? P2.5. It is the sixth pin of port 2. The sixth pin of port 2 now will be clear, and if it is false, then this will be executed, where again the sixth pin of port 2 will be carrying logic 1 now. So after executing this, again it goes to read switch, from here also read switch. So what happens? By checking this condition on fifth pin of port 0, the sixth pin of port 2 will be changing its state. If it is 1, it may be 0. If it is 0, it may be 1. So this is what is the logic of interfacing our push button to 8051. Let I demonstrate this using Kyle software. Here is a Kyle software. Then here also again go to project, create a new project, give the name to the project. Say I have given it to be yes, sorry, capital I'll give yes W1. Say yes switch 1. Say save. Once you save, you will get this menu. Go to the device place. Yes, select select legacy device databases, then come down here. Here you have to select generic option, go to generic. Yes, here is a generic. Then here you have to select 8051, say OK. yes, then copy this, yes, say copy to the folder, then say yes, overwrite this one, yes. Yes, your project is created. Now go to project target one, right click that, then you will get option for selecting target options. Then check whether it is 12 megahertz or not. Select 12 megahertz. Then you have to go to output. Then here create hex file. Then say OK. Your project is created and configured. Then you have to go for source code. Now you have to write a source code. To write a source code, go to file, say new. Here you can write assembly code or C code and start writing. There you can copy the existing code. Yes, it is copied the same program here. Then say save. After saving, give the name of the file with the .asm extension. Say I'll give here sw1 asm.asm. It is assembly code. Say yes, save. Yes, you can see that file has different colors now. Then you have to add this to the group. Say source group 1, right click it. When you right click, you can get option add existing files to the group. Then say click that. Then you'll get this menu. Search the file that you have created. Say yes wasm, yes sw1 asm.asm. Select this. Say add. After adding, yes, you have selected. Now you close this. Then now it is ready for execution. Then you have to compile this first. Go to translate menu. Click this and it will check for errors. Now there are no errors and warning. It is a perfect program. Then go to say build. It will create a hex file. Yes, hex file for the same project is created. Now the same thing you can burn into 8051, or here you can see the simulation way. Then go to this debug mode. Say debug session. Click this. You say yes evaluation mode. Yes, you are here now to check how this code will work without having IO devices connected. Go to peripherals. Yeah, used a P2 and P0. So select two ports, IO ports, port 0, bring here, then again go to peripherals, then select IO port 2, then arrange it properly for good visualization. Yes, now we are ready for execution. Then yes, you can see that fifth pin of port 0 and sixth pin of port 2, and fifth pin of port 0 is programmable. That is, it is a switch is being connected. Depending upon that condition, then the sixth pin of port 2 will be changing. So these changes we will see now after executing. Then go to step by step execution. Go to this, say click now. Once you click, control goes here, then no changes are seen because the default value on the ports will be 1. So it is set. So jump on no bit, it is false, so it will come set port sixth pin of port 2 also. Then again execute, press again, then press again, same thing will happen, nothing. So, because default ports will be carrying logic high. Now in order to change this, we have to see the input, say the input pin. So what is input pin? It is port 0, fifth pin of port 0. So now uncheck this. That means it is carrying 0. Now when you execute this, you check the sixth bit of port 2. Yes, it is unchecked now. So it is 0 now. So depending upon the condition on fifth pin of port 0, the sixth pin of port 2 is changed now. So this is how see again. Yes, now again check. Yes, it is pressed now. Yeah, execute again and see the sixth bit of port 2, it is again high. So this is how you will be executing on simulation mode. So it is perfectly running now. Then you can convert this into hex code and burn into 8051 IC and connect the required hardware. then it will start running. Yes, let's look at the interrupts of 8051 in the next lecture in detail about how 8051 can handle interrupts. Then there I will see in details. So thank you, thanks for listening.